And thank you guys. There we go. And thank you guys for being here. I really appreciate it. As Tara mentioned, I'm currently an intern with the Friends group, as well as I actually this is the research for my master's thesis. To give that context, I just defended it. It's been accepted, and so I'll be graduating next month in early August. And just so that technology runs smoother, I'm going to go ahead and turn my camera off if I can figure out where that button went. Sorry, I gotta. Whoop, whoop. Where did? Sorry, I'm bad with technology, guys. Where's my camera? There we go. Okay. Share screen. We are all good. No, we're not.
Yeah, can you make it full screen, Alex?
I'm trying. It's not showing anything. Can you see my screen?
Yeah, I can see your
Okay.
slides. It's just not full screen. There you go. You're good.
Okay, awesome. I'm sorry for those technical issues, but now we are ready to go. Okay. So to start, we're going to talk a little bit briefly just about wetlands, why they're important, why we need to restore and take care of them. So wetlands provide services or benefits to the environment. So typically in the science world, we'll hear these referred to as ecosystem services. And we are really focusing on the services that they provide to the environment and being part of that ecosystem. However, humans can also gain services from these wetlands as well. So these wetland services, we're going to break them down into provisioning, regulating, supporting, and cultural. So in provisioning, think fish and mollusks for sustenance, drinking water, water for irrigation. They can also provide timber and peat. And then when we go to regulating, think retention of soil, sediment, and nutrients. And this process here is really important in abating harmful algal blooms and promoting positive water quality, as well as wetlands are really critical for flood control and buffering. So as water, rains down and it moves through our landscape, they kind of hit wetlands before they go to, for us, it would be Lake Erie, but whether that be another water body, a different basin, a ocean, and it kind of acts like the kidney. So people call them the kidneys of the ecosystem. So kind of like your kidneys help filter out your blood. The wetlands are helping filter out that water, keeping those soil and the sediments and the nutrients in place in those wetland soils, as well as it's slowing that down so there's not as much flash flooding. And additionally, in regulating, wetlands also provide areas for recreation and tourism. And then in supporting, wetlands also provide habitat for a wide range of flora and fauna. So specifically looking at the wetlands, the coastal wetlands on the southwestern side of Lake Erie, they can house about 33 species of amphibians, 51 species of mammals, 50 fish species, and numerous migratory and resident birds. I believe that number is just over 300 at any given time, including migratory and resident. And they're also home to protected and vulnerable species, such as the eastern prairie fringed orchid, bald eagles, Blanding's turtles, barn owls, and the Lake Erie water snake. Additionally, in supporting, wetlands are critical for soil formation through that sediment retention, as well as the aggregation of organic matter, and that also functions in carbon sequestration. As well as the cultural services. So they provide places to reflect on religious and spiritual values, educational opportunities, as well as cultural heritages. So these wetlands were home to humans long before European colonization occurred. And in those cultural services, it's important to highlight that in 2024 alone, Ottawa National Wildlife Refuge had greater than 400,000 visitors. And here, these people are taking place with any number of activities: wildlife photography, hiking, biking, kayaking, fishing, hunting, as well as educational programs and workshops. However, these wetlands have not always been valued and appreciated or taken care of as they should. So the wetlands of the Great Black Swamp, which includes Northeast Indiana and Northwest Ohio, so the area that the refuge is situated on, have experienced extensive degradation. So with that, over 96% of the Western Lake Erie coastal wetlands have been drained for agricultural purposes since the 1860s, and many others are diked and hydrologically isolated, and this helps with waterfowl management and human development, but isn't the best for the overall health of the wetlands. And so when we talk about diking, I'm sure many of you have been out to the refuge before, so it's usually those earthen barriers between water bodies, between wetland units. They're not all bad though, but they do separate the hydrology of the lake back to the wetland, but they're great for actually managing the habitat there. So when these habitats are degraded, it minimizes those ecological services that we previously discussed. And this leads to degraded and fragmented habitats, as well as it reduces that nutrient retention that is so critical in helping abate those harmful algal blooms. So it leads to an increase in those algal blooms, an increase in turbidities or suspended solids within the water column, as well as just a general decrease in water quality. And keep in mind that these areas, especially the lake, are providing drinking water to many, many people. As well as this, degradation can lead to an increase in invasive species. So a little bit of background on the refuge. This is probably not new for anybody, for many people here. So it was established in 1961 for the purpose of managing and protecting migratory birds specifically. However, the 2003 Expansion Act expanded that mission, and that now includes the protection, restoration, and the management of wetlands. It acts as stopover habitat for waterfowl and migratory birds, as well as to protect endangered and threatened species, as well as their habitat to bolster that biodiversity. And we also need a little bit of background on the Great Lakes Restoration Initiative. So this was started in 2009, and what it is, it's a multi-agency effort by the federal government, and is providing funds to 16 different agencies to target prominent threats to the Great Lakes ecosystem. Some of the long-term goals of the Great Lakes Restoration Initiative that were critical to this project here are community and economic revitalization through restoration and protection, making water safe for recreation, keeping the habitat protected and restored to sustain healthy ecosystem function and the native species that inhabit it, and creating a more resilient ecosystem as we face a changing climate and other stressors. So a little bit about the actual reconnections that I studied. So these are fish passageways that were funded through that Great Lakes Restoration Initiative. They're actually all at the refuge. So what you see on the picture to your left, that is along the hiking trail. So what you see right there is the hiking trail, and the other side would be the estuary trail. And so what you're seeing is the above ground connection between the radar ditch there and pool 2C, which would be, as I'm taking that picture, at my back. And so what these fish passageways do, they connect those wetlands back to that hydrology of Lake Erie as they naturally would have been. As well as these also serve as water control structures. So they can be used to raise or lower the water levels in the wetlands. And that's really important to be able to have that management of the wetlands. So we're trying to balance being able to manage those water levels, but also providing that connectivity for the aquatic species. And with being able to manage those water levels, the managers at the refuge can help manage that for foraging habitat for shorebirds. You can change those water levels as habitat for fur bearers, for waterfowl, as well as for managing invasive species. And so the picture that you see on the left is actually what the pipe would look like underneath those dikes. So that's what's actually connecting the creek to the wetland itself. They're high density polyethylene pipes, so it's a really thick, strong corrugated plastic. And they're all about 36 inches in diameter. And the length ranges just depending on the width of the dike that they're connecting. So most of them tended to be around 16 to 18 meters or about 50 to 60 feet. And the issue here is we were actually approached by the refuge saying, we've put in these projects, however, there hasn't been a ton of post-monitoring to understand if they're actually serving as connectivity for the fish community here. So that's where I came in with this project to hopefully better understand how they were impacting the fish community at these sites and in these wetlands. So that leads me to the objectives of the project. So the first one was to quantify the patterns of fish movement through the passageways. So are they using the passageway? And if so, what do the patterns of that usage look like? The second objective was to identify the fish community using both sides of the reconnections. So what species are actually present there? And the third was to survey users of Ottawa National Wildlife Refuge to assess the public perception and interaction with restoration projects. So when building this project, I had my career goals in mind, and I know I really enjoy the science aspect, as well as getting out there and working with the people themselves that actually enjoy these public lands. So I wanted to make sure I was taking that aspect into account. So that's where objective 3 comes in. And so as I move through how I did the results I got and what it means, I'll be referring back to these objectives. So first, the study sites themselves, I had 3 reconnections I looked at. All of them are within the Ottawa National Wildlife Refuge complex, which is on the southwest shore of Lake Erie. So one of them is on the main property, so that 2C to radar ditch connection, and the other 2 are on a satellite property, which is not open to the public, Darby Marsh, and that's a little bit further east towards Port Clinton. And all of the sampling occurred last summer in July and August of 2024. And so the picture that you see, that's me actually in one of the boats getting ready to pull those fish nets that I'll talk about here shortly out of the water. So here we have a map for you. I'm sure you guys are really familiar with this. So in the top left in that outlined green, that's the main unit of Ottawa. And then on the bottom right, as you follow Route 2 towards Port Clinton, outlined in the red, you'll see the Darby Marsh unit, and that's where the other 2 sites were. So zoomed in here, this is where the site on the main property was. So you can see down here, I'm not sure if you can see my little pointer. This is where the actual structure is, and it's connecting pool 2C to the radar ditch, which leads out to Crane Creek and eventually the mouth of Lake Erie. And like I said, these are the hiking trails in here with the estuary trail on the other side here. And as I mentioned, the other 2 sites are at Darby Marsh. So here on the left, we have Darby Marsh Pool 1, and on the right, further east, is Darby Marsh Pool 4. Here are the structures, and they're both connected to LeCarp Creek, which flows in here all the way around, and once again, here at Lake Erie. So this site DMP1, so let me go back really quick. So the one here on the left, DMP, so I'll refer to them as 2C, DMP1, so Darby Marsh Pool 1, and DMP4, Darby Marsh Pool 4. DMP1 presented us with a really unique opportunity. Management had actually had the actual water control structure itself closed for about a year. And so with it being closed, we took that as an opportunity to do a pre and post restoration simulation. So I actually sampled it while the structure was closed to represent a pre-restoration kind of situation. And then the structure was opened as if the restoration was just put in. It was sampled after. So sites DMP4 and 2C had been open to the lake for at least 2 years. So those each sampled once because we knew it wouldn't change a ton because it was already there. A little bit about how I did what I did. So that first objective, the actual patterns of fish movement, I called a dual frequency identification sonar. We call that a DIDSON, and that is actually the mechanism or the system that you see here on the right, this like black box. And what it does is it provides video output, and it's non-invasive. It's kind of just like taking a video, and it's really good because you can't necessarily put a camera, like a camera trap like you would for deer in this because of the depth, because of the turbidity, and the water would affect those systems. So the sonar is able to give us that visual into these systems. And I set it up with one system on each side of the connection pointing into that structure, so into that pipe that the fish actually move through. And it had collected for 72 hours straight. So the goal with this was to visualize the fish moving through the pipe. So the hope was that we would catch fish on one Didson moving through the pipe and catching it on the next. And the hope was to exclude the milling behavior. So some previous research that's been done at the Crane Creek fish structure at Pool 2B has seen milling behavior where the fish swim around the outside of the pipe and they kind of just hang out, but they never really go through. As well as we're not sure if fish maybe go in the pipe, go halfway, and are like, no thanks, and turn back around. However, there were some technical issues and power outages, and that was not didn't notice that with the video files until much later. So we had to adapt the plan to the data that was available. And so I had incomplete 72-hour periods, and there wasn't full footage on both sides of the reconnection. So I was able to take one side per site that had at least 24 hours of footage and make a 24-hour pattern with that. And the picture that you see on the right, that's me working with another graduate student explaining the kind of on land structure. So that picture I showed you of the system, it goes into the water and it is connected via these cords to the laptop that is actually taking that data and making it into a video. And that's also its power source. And it would be stored there for the entire time it was collecting. So on the left here, this is actually what the output of the sonar gives us. So you can see these little blips here. Those are all fish. And so I had that 24-hour period for each site, and I did a manual counting method. So for each of these sites, I watched a 2-minute period per hour. So I watched minutes 10 to 12, 29 to 31, and 50 to 52. And I would tally up all the fish I saw within those 2-minute periods, sum it up, and I would extrapolate that to fish per hour. And as needed, I would pause for large schools. So sometimes they would be coming in 20 at a time, just pause, count all the fish, continue on. I see a question in the chat asking me what fish do we see there. So the issue is they all kind of just look like blobs. And it's hard to tell actually what fish are there. So that leads me back to objective 2. This question segued perfectly. And so objective 2 was actually what fish are there. So I can see that there's a fish on the sonar, but I can't see what type of fish. Especially fish that are really close related, like green sunfish and bluegill. They're so similarly shaped that you wouldn't be able to tell. So I used what was called a pike net, which is what you see in this image above. And this was placed down into the water, and the fish will kind of hit this net, they swim along, and they moved into this rectangular metal frame. And as they continue to swim along, these nets are actually subsequently smaller and smaller and act like a funnel, and it is tied off here in the back, kind of like a bag, catches them all in there. They can't swim back out the other way because of how it gets smaller and smaller and tapered at the end. And that's how I would collect them. So with that, these nets, there were 4 at each site, 2 per side of the reconnection, and they were set for 24 hours, after which we pulled the nets up. We identified the fish to species, and their total length was measured. After that, they were then returned happy and healthy back to their respective habitats. And I had 2 net sets at each site. So set it for 24 hours, pull it, reset it, let it sit for 24 hours, pull it out again, and I did that across all 3 sites. But we do need to note, again, site DMP1 was sampled twice. So before the structure was opened as our pre-restoration, it was opened, and then about 2 weeks after that opening, it was sampled again. And to objective 3, how did I go about this? A survey was sent to the permitted hunters from the 2024 Controlled Hunt Program at Ottawa National Wildlife Refuge. And why this subset of the recreators there? Most people that come and recreate, they go for a hike, they go bird watching, and then they go about their day. They don't have to have a permit. They don't have to kind of sign in a visitor log. It would be great if you do, though. But they don't really give contact information. Whereas with being a part of the controlled hunts, they have to have a permit and they have to provide their contact information as a way to speak with them and as well as safety. So we were able to contact and work with them for that. And these questions asked about their history recreating there, their knowledge of wetland restoration, their perceived value of these projects, and whether or not they consider themselves conservationists. And how I went about actually analyzing the data. So what I looked for was, is there an effect of time of day on fish movement? Which of these sites had distinct temporal distributions? So were any of the sites vastly different from the others? Does the movement during the day differ from the movement during the night? And I looked at, there were some key points when I show you on a graph what the movement looks like. There were some key points where there were really big changes in the amounts of fish moving. So I looked at percent change during those time periods. So 2 hours before sunrise and the first hour after sunrise, the hour leading up to sunset, and the 2 hours after sunset. So what was the magnitude of change occurring during those times where the fish movement was really different? And when analyzing this, daytime hours were considered 6 a.m. to 9 p.m. So keep in mind this was July, August. And then the nighttime hours were then 10 to 11, and then midnight through 5 a.m. So for like that percent change, the fish per hour for an hour, so 4 a.m. to 4:59 a.m., was then compared the percent change to 5 a.m. to 5:59 a.m. And with these, I was using statistical analyses tests, and it was to see if the results were marginal or significant. Just for ease of explanation, I removed the fancy terms and all of that stuff, but I would be more than happy to discuss that if anybody is a stats nerd. I'd love to get into that. Okay, so how did I go about analyzing objective two, the fish community? So they were analyzed by feeding guilds, so grouping them by how and what they eat. So the first grouping was benthivores. So these are fish that are swimming along the bottom of that water column, and they're eating a lot of crustaceans as well as a lot of detritus and vegetation that's down there. So this was mainly common carp, channel catfish, and bullheads, which are a type of catfish, and they come in the yellow, black, and brown variety. And then we had piscivores. So these are fish that eat other fish. So kind of the apex predator of the fish world, if you will. So these included bowfin, black crappie, and northern pike. And then the last grouping, which was invertivores and planktivores. So fish that are eating macroinvertebrates, so small kind of aquatic bugs that don't have backbones, and zooplankton floating in the water column. And this made up a lot of species that you'll find at the refuge, including bluegill, green sunfish, pumpkin seed, gizzard shads, and golden shiner. And so to look at this, what I was really looking to see was, are the communities of each habitat type different from one another? So I looked at the wetland and the creek at site DMP1 prior to opening. So prior to opening, was the wetland different from the creek? As well as were the wetland and the creek different after opening? And then I looked at the wetland and the creek together at site DMP4, and then the wetland and the creek at site 2C. So what did I actually find? So I found that the number of fish moving per hour during the day was different than the number of fish moving per hour at night. So daytime movement was 62%, 29%, and 20% higher across all three of the sites. So there is a effect of time of day on the numbers of fish moving within these wetlands. And all three sites were distinct from one another. So here we have a graph. This is showing what I actually found from those DIDSons, the sonars, showing fish movement. So at the top, we have site 2C, the middle is site DMP1, and the bottom is site DMP4. Going across your x-axis, so horizontal, on the far left over here is midnight, and we move through the day with sunrise being here in this first red rectangle. We continue on through the day, and sunset at about 9 p.m. is here in the other red rectangle. And on the y-axis, so vertically up the left, that is the amount of fish per hour. And you'll notice that the amount of fish per hour was different at each site. But what we're really seeing here is, even though the total numbers of fish differ between sites, the patterns are holding true. So we see at night, so here is midnight, 1 a.m., 2 a.m. There's very little movement occurring of these with these fish. When we get to sunrise, this is when it starts picking up, right before sunrise, and we jump up here at sunrise. It wavers a little bit during the day, but it's mostly holding steady. And then as we start approaching sunset, it goes down greatly. And then once again, it's pretty low throughout the night. So the key takeaway here is that this pattern is holding true across all three sites, with sunrise and sunset being those times when change is occurring in the fish movement numbers. So here we have those percent changes. So above the red line, we have 4 a.m. to 5 a.m., 5 a.m. to 6 a.m., and then 6 a.m. to 7 a.m. And we can see at site DMP1 and DMP4, we're having large increases in fish movement for the most part. At site 2C, they held pretty steady, but as we hit sunrise, they're going to sharply increase. Below the red line here, we have that approaching sunset and at sunset. So That would be 8 to 9, 9 to 10, 10 to 11. And for the most part, we are seeing pretty big decreases in the fish movement per hour across all three of those sites. So what did I actually find with the fish communities? So site DMP1, keep in mind this was that pre and post restoration. So before opening, these communities, the wetland and the creek, were significantly different from each other. In the wetland, there were 6 families, 12 species, and 300 total fish. And this was mainly black crappie, golden shiner, gizzard shad, and brown bullhead. So all 3 of those feeding guilds. And on the creek side, there were 5 families, 9 species, and 124 total fish. And that was mainly gizzard shad and bluegill. So mainly the planktivores and the invertebrates. And so here is a visualization of that data. So moving across our x-axis horizontally, we have the benthivores, the piscivores, and then the planktivores and vertivores. Your y-axis is total number of fish, and the green is the creek, and this purplish blue is the wetland. So we can see that overall the wetland had more fish, mainly dominated by those piscivores, but it still had a fair number of those other 2 categories. Whereas on the creek, total catch was lower, and it was mainly planktivores and invertebrates there. So we're staying at that same site, DMP1, but now after that fish structure was opened. And now there is not a significant difference between those communities. And so what we're seeing is the wetland had 5 families, 9 species, and 75 fish total. So a huge decrease in total catch compared to before the opening. And this was mainly bluegill, black crappie, and gizzard shad, so mostly planktivores and vertivores with some of those piscivores. And on the creek, we had 7 families, 15 species, and 180 fish total. And that was dominated by bluegill, pumpkin seed, and bowfin, so mostly planktivores and vertivores, and again, some of those piscivores. So here's a visualization of that. So we have the same X and Y axes as before. And we can see here that now the creek has higher total catch, but it is really dominated by those planktivores and invertebrates. And then over on the wetland, the total catch was lower, but it has that same pattern of a few benthivores, a little bit more piscivores, but mostly planktivores and invertebrates. And now we're going to look at site DMP4 and 2C, and those, just for ease of visualization, we'll talk about them both, and then they'll be on the same graph together. So at site DMP4, there was a difference between the communities. So there was a difference between the fish community on the wetland side and on the creek side. And so there were 6 families in the wetland, 12 species, and 213 total fish. This was mainly bluegill, black crappie, largemouth bass, and pumpkin seed. And so mainly planktivores and invertebrates with some of those piscivores. And on the creek side, there were 7 families, 15 species, and 154 total fish. And that was mainly dominated by gizzard, shad, and bluegill, so almost exclusively planktivores and invertebrates there. And then when we look at site 2C, again, there was a difference between the wetland and the creek communities. On the wetland, there were 7 families, 12 species, 63 total fish. And this was mostly bluegill and black crappie, so planktivores and invertebrates, as well as piscivores. And at the creek, there were 6 families, 12 species, and 61 total fish, mainly pumpkin seed and bluegill, so almost exclusively planktivores and invertebrates there. And so visually for this one, we have site DMP4 at the top and site 2C at the bottom. And this is the proportion of fish on your y-axis. So what is the kind of, how much of the total catch did that grouping make up? So in this purplish, we have the planktivores and invertebrates. The piscivores are this the next largest chunk, which is that bluish, and a very tiny chunk in that mint green is the benthivores. So we can see at both sides there was total catch is low at 2C. It just happened that way for the Ditson and the fish community. But again, those patterns are holding true of both sides being dominated by the planktivores and the vertivores, more piscivores, very few benthivores, but the wetlands having a little bit more of an even distribution compared to the creeks. And to kind of put put that into words, general trends. Prior to opening, the creek of site DMP1 was dominated by planktivores and invertivores. After that fish structure was opened up, it increased in the benthivores and the piscivores. And the wetland had an even distribution of all three feeding guilds to begin with, but opening led to a decrease in total fish abundance, and all three feeding guilds, of course, with that as well, went down. And the sites DMP4 and 2C were dominated by planktivores and invertivores. And the wetland had a higher chunk of piscivores and was really, really low in benthivores. Overall, total catch was higher in the wetlands, and the only exception to that, the only time that catch was higher in the creek was at site DMP1 after opening, so after that restoration simulation occurred. And now the results for the survey. So objective 3, overall 188 individuals were contacted to participate in the survey with about 28 respondents. I say about because there were some questions where they could not answer at all, or the very first question asked them, which hunt did you participate in, and gave them a checklist. And some of them did participate in both deer and waterfowl, so that kind of gave it more responses. And the questions asked respondents to rank based on a scale of 1 to 10. And it would say, how do you feel about this? 1 to 10. 1 is always low knowledge, low priority, low value. And the 10 was the scale for high knowledge, high priority, high value. So we will look at some of these through a pie chart. So the first question that we have here at the top, it asks them about to rank their knowledge of ecological restoration and wetland conservation. And for the ease of visualization, those were grouped in twos. So we have 1 to 2, 3 to 4, 5 to 6, and so on. So starting here in the red and moving counterclockwise, we have the low knowledge. So this is what they are ranking, how they feel their own knowledge of restoration and wetland conservation. So we see a really diverse answer here. So it's pretty well spread out. Some saying 1 to 2, a large chunk in that middle range, but another big chunk are saying 9 to 10. So it's pretty dispersed. You'll see with the rest of our questions, it wasn't as dispersed. It was much more clear cut towards one end or the other. So the next question asked them how would they rank the importance of ecological restoration and wetland conservation? Same colors, same groupings, and our lowest received was a 7. So they think this is pretty important. So starting here in the blue, that's 7 to 8. And over 50% of people ranked that in a 9 to 10. So very important to them. Next, this asks them about the allocation of tax dollars going to ecological restoration and wetland conservation. So again, same colors, same groupings. The lowest value we have is here in this green, and that is a 5 to 6, so about that mid-range. And then as we go counterclockwise, again, increasing. So 7 to 8, and then just under 50% saying 9 to 10. So most of them think it's mildly important or pretty important that tax dollars are being allocated to these projects. And then we have their perceived value of these projects specifically at Ottawa National Wildlife Refuge to local habitat and wildlife. So how valuable do they think these projects are to the habitat and wildlife here at Ottawa? We have a small group here saying 1 to 2, so they don't think it's very valuable. Increasing, we have a few in the 3 to 4. We have a decent sized chunk here in the 7 to 8. But again, that's just shy of 75% of respondents saying 9 to 10. So for the most part, they think these are of great value to the local habitat and wildlife. And lastly, we asked them, do you consider yourself a conservationist? So first we have in the red, that is definitely not. The other end of the spectrum, definitely yes, in this sort of olive green. And then we have might or might not in this green here, and probably not in the blue, and probably yes in that purplish. So you can see most people, so over 50% are saying definitely yes. We've got another good portion saying probably yes, and some others are kind of on the fence. So to put into words, what do these things actually mean? So these structures are providing ample access as a fish passageway. So they are acting as both water control structure for management purposes, as well as providing connectivity so these fish can access both the creek and the wetland habitat types as they need. And so we were seeing 61%, 77%, and 83% of that hourly movement is occurring during the day across those three sites. Overall, across all three sites, more than 78% of all movement occurred during the day. And those substantial changes in time when the fish movement is occurring is around sunrise and sunset. And these patterns actually match other research that has been done at the refuge. So Kowalski et al. Has done quite a bit of research at the Crane Creek and Pool 2B structure. And they have also found these same patterns of most of that movement occurring during the day, with less of it moving at night, and those same time periods of sunrise and sunset being those important time periods of change. And Keaston Welsh did a lot of research regarding what these fish eat. So, what is their diet made up of? And when are they going out and feeding and foraging for their prey? And so they have found that when they choose to go find their food is likely what is causing these patterns. So it's likely due to dissolved oxygen in the water and those feeding behaviors of the specific fish that are living in these habitats. So what we saw is that both sides of site DMP1 had different communities prior to opening, and they were not different after that reconnection was opened. So likely what occurred there is the fish were given the opportunity, especially the ones in the wetland, to go out and explore that new creek habitat. And likely they did go because the numbers of total catch on that wetland went down greatly after it was opened. And the communities between the wetland and the creek at sites DMP4 and 2C were different. Once again, different habitat types. And the fish communities spanned multiple trophic levels. So you had fish that eat other fish that eat little bugs, fish that eat plants, fish that eat detritus on the bottom. So you have a little bit of everything to make sure that community is filled out and robust. As well as, I didn't present it here, but I had that size data. And we had the same species of fish in unmeasurable young of year that could fit on my nail to greater than 100 millimeters. So we had fish across all sizes. So we know we've got baby fish, we've got adult fish that are breeding and reproducing. So it's a healthy community. And for that hunter perception survey, overall, they were supportive of wetland restoration projects, and especially those that they have encountered at the refuge. A large majority of themselves consider them conservationists in some way. And this is really great to see because public support is of great importance for restoration projects as well as supporting public lands. And that's through whether it be awareness. So maybe you guys went to the refuge, you have a great time, you go tell your friends, go support this place. It's a great place to spend time with your family. Showing up and supporting at maybe public town halls for restoration projects that they would like to then take place, as well as donation of time through volunteering and donation of money. And it's important to note, prior research has shown that educating the public on environmental topics, and especially the benefits that those environmental restorations can have, can then lead to increased community support. So the big take-home message, this was only 3 sites in a small geographic distance. And so to apply this in a broader context, and they only did occur in July and August. So to apply it in a broader context, it would be important to look at seasonality and multi-year patterns. So with that seasonality, you do see a greater distribution of fish occurring at different times of year. So for example, northern pike, which are a popular game fish, they're one of the first fish after the ice has receded off of the lake in about February, March. They start to come into the wetlands, they lay their eggs, and they quickly leave and they are out by about late April, early May. So by expanding the time periods, you could get a better look at, okay, is the fish community then different at different times of year? As well as multi-year patterns would be important to look at as well. And then also understanding that this is just the fish community, and these restorations, as well as the fish themselves, are not existing in a vacuum. So there should be more work done to include the aquatic and semi-aquatic biota. So how are plant communities differing and how do they play into this? Amphibians, reptiles, macroinvertebrates, mammals, birds. Looking through that Ditson data, I saw what I think was an otter swimming through one of these connections. I saw plenty of turtles on that sonar. So understanding that there are other creatures, as well as plants at play in these communities. As well as it would be good to understand the environmental variables that are at play here. So I mentioned dissolved oxygen. So there is oxygen dissolved in the water column, and that's actually how fish and other aquatic organisms go through cellular respiration and how they breathe. And those levels of dissolved oxygen can actually vary at different times and greatly throughout the year. So in the summer, especially in these shallow wetlands, that oxygen can get down to nearly or sometimes zero. And that can affect the fish movement, and maybe they would prefer to be in that deeper, cooler, moving creek habitat. As well as water temperature varies greatly, and light levels within the water column, as well as moving into that pipe. And so our big take-home message here is that healthy wetlands are part of a resilient ecosystem. And what we're seeing with these current restoration techniques is that it's providing progress to restoring wetlands. So it's giving these land managers the opportunity to both manage those water levels as well as provide connectivity for these creatures. And we've also seen a strong demonstration of public support for the restoration of these wetlands, which is great. We'd love to see more. We'd like to keep that going. And hopefully this can inform land managers as they continue to implement restoration projects. And so with that, I do have many, many people to thank. It truly takes a village. This work was done through my master's program at Bowling Green State University, within the Department of Biological Sciences, as well as I'm a part of the Center for Great Lakes and Watershed Studies. Both of those entities gave me funding to help actually make this research happen, to travel, present this research, get the good word of wetland restoration out there, as well as my committee. So the professors that helped me out with this, Dr. Jeffrey Miner, Dr. Karen Root, Dr. Kurt Kowalski, who is with the USGS up in Ann Arbor, and Dr. Dan Wiegman. Of course, massive thank you to Ottawa National Wildlife Refuge. They had this idea for this project and we made it happen. As well as they've really helped support my career through internships. And a special thank you to Trevor. He made the maps that were used in this presentation as well as in my thesis. Of course, thank you to the Friends of Ottawa National Wildlife Refuge. I could go on thanking them for hours and days and start crying about it because they are so wonderful. The work they do is incredible. And they have really helped. They're like a jetpack that has taken my career up and off. And it's been really wonderful to get to work with them, to learn from them. And it's been a really, really great opportunity. And then thank you to my lab mates, Kaya Daig, Joe Toth, and William Bell. They were out there getting muddy, getting dirty with me, helping with that, as well as bouncing ideas off of each other in our office. And I had many helping hands in the field that also often serve as emotional support humans. So my parents actually got to join me out for field work, and it was super fun getting to show them what I do in my work days. It was kind of the opposite of take your kid to work day, as well as I had some awesome support from my friend and classmate Maria, my significant other Tad, and Basha, the park ranger we all know and love. She, of course, was out there getting muddy and dirty with me too. And so with that, I would be happy to take any questions anybody might have. Let me all see you. If you have any questions, feel free to throw them in the chat, unmute yourself. I would be happy to talk all day about fish. Thank you, Sir Castalot.
I do have a question for you.
Okay.
What was the most surprising thing that kind of shocked you that came out of your research or your study?
Oh, goodness. Huh. Most surprising thing. I was honestly really surprised when I was going through that Didson and I would pause it and I'd be like, what did I just see on there? And I have sent that video to other people at the refuge and we think it was an otter, but we were like, oh my gosh, are there mermaids in Ohio? It was it was crazy because I was like, what is it? But it was cool to see that there were things, I was looking at it for, but it was cool to see other things using it. But I was like, those can be kind of wide depending on the length of the dikes. So it was just incredible that they were able to swim through that, and some of them have those beaver grates on it. So it was really surprising they were able to go through that whole thing as well as the turtles. That was crazy.
Okay, thank you.
Yeah.
Are there any other questions for Alex?
Alex, I got one for you. What is the most
Okay.
exciting that you happened to catch when you were at Ottawa?
Bowfin. I had a ton
I
of
knew it.
bowfin in my nets, and I've caught one or two actually recreationally with my pole at that 2C connection out like fishing legally from the estuary trail. They're awesome. They put up a heck of a fight if you're catching them recreationally, but if you guys don't know what bowfin are, they are one of the oldest ancient species of fish. They can actually breathe air, and when they are spawning, their mouths and their fins turn green. They're just the coolest little dudes ever. Little dudes, they're pretty
Awesome.
massive fish.
Anyone else have any lingering questions? Okay, I'm not seeing anything. So thank you so much, Alex, for doing this presentation. It was great, learned a lot. And then thank you everyone for coming out. If you joined us late or didn't miss or missed a couple of things from the presentation, this will be sent out afterwards in a couple of days, the whole presentation, so you can always rewatch it if you happen to come in late or miss parts of it. But other than that, we're going to sign off. So thank you again, Alex, and make sure you check out the Friends of Ottawa page, and all of our events will be posted on there with everything coming up.
Thank you guys for having me.